Hello, I'm Dr. Taylor, and welcome to Dr. Taylor's Pedagogical Notes. All right, we're going to take a look at whole number multiplication. Now, many people struggle with multiplication. They want to memorize. They want those multiplication facts. I hear teachers talk about how kids don't come with it. This is meant to build those facts from concrete to abstract, to build up those math facts without breaking out, without spending days drilling and killing on math facts, without making people feel badly because they haven't memorized or their memorized things were forgotten. If we contextualize with understanding, kids will remember through exploration, I guess is the right word. So let's take a look at it. All right, again, everything going from concrete to abstract, and there's my links. So let's start with concrete. First, we're going to take a look at what's 4 times 3. Okay, what the times? That times, what does times mean? Well, you know, what if I got fired from my job 3 times? What does that mean? That means I got fired, and I got fired, and I got fired. That's what that means. Now, thank God that that's not the case, because I'd be losing my house and losing my car and not eating, right? So that would be horrible. This is not what we're looking for, but I wanted to give you an example of how what times really means. It means a number of times something occurs. So 4 times 3, I could look at that as 4 appearing 3 times or 3 appearing, that's right, 4 times, right? So it depends on which way I read it, and we'll talk about why we can read it in any direction. In fact, we'll discover, because maybe we can't. Let's discover together. All right, so there is 4 colored squares. 1, 2, 3, 4. 4 units makes a 4, right? I could squeeze them together and it would become a strip diagram, right? I got 4 colored squares. So that's 4. But what does the problem say? 4 what? It says 4 times 3. So that means that 4 has to appear how many times? It has to appear 3 times. So I'm going to use another 2 rows of 4. So now I've got a row of 4 once, a row of 4 twice, and a row of 4 3 times. That represents 4 times 3. Okay? You can see how you could squeeze them all together if you want, but right now, could I not just count them up? What is 4 times 3? That's right. It's easy to do. We simply count the squares. And I'm just going to tap it as they go, and you can be counting along with me, and you end at 12. So 4 times 3 is 12. Now let me ask you a question. When I look at this, is this 3 rows of 4? Or, just bear with me, is this 4 columns of 3? Which is it? Could it be both? Right? Could I not only be a student, but a teacher? Could I be in college and teach school? Could I be more than one thing simultaneously? Of course. And so, can I have more than one condition describe a scenario? Sometimes, yes. Many times, actually. All right? So this is the most rudimentary method, but it still is valuable and powerful, particularly when the numbers aren't very large. Okay? If we simply made each of the rows a 4, you can see that 4 and 4 and 4. I could skip count 4, 8, 12. Right? So there it is, getting squished together. You can see now that's 3 4s as a strip diagram. Just the same thing. 4 times 3 is 4 plus 4 plus 4. This is what's called repeated addition. How many times did I add the 4? 3 times, because that's what it said. So I repeated the addition as many times as it said. In this case, since I grouped into 4, I repeated it 3 times. Had I grouped them into 3s, I would have repeated it, that's right, 4 times. Okay? All right. So this is called repeated addition, and it's a powerful tool to get you to those multiplications that you don't know. Don't just grab your phone every time. Consider using repeated addition and grouping to get to the number, then grab your phone and check it. Build your skills. The phone can die, it can drop, it can get lost, it can get squished. Then what do? If you can't do anything without your phone, then you're worthless, right? You're going to be able to do nothing for your group or your company or your team. But if you can use your phone to reinforce your mental skills and then accentuate them beyond what you can do, when your phone's gone, you still have some basic skills that are going to be valuable to you and whomever you're working with on whatever you're working on. Okay? So that's why it's important. It's not just to make it harder for teachers, it's to make it smarter for you, to make you more prepared to problem solve and more confident about your preparation. Okay, that's repeated addition. These could be pushed together vertically, right, to create an area model. Huh, look at that. What is the dimension of that shape? What is that shape? Looks like a what? Kind of like a square, but not quite. It's really actually not as specialized. It's called a rectangle. And a rectangle has dimensions. It has a length and a width, or a height. So the question is, how long is it? And how tall is it, right? Okay. Oh, it's 4 long and 3. So I could say that that rectangle is 4 by 3. 4 by 3. Notice how 4 by 3 looks like 4 times 3. So what do you think you do with 4 by 3 to know how many squares are in that shape, which we commonly call the area? You would multiply. Notice that 4 by 3 is also 3 by 4, isn't it? That lets us say that 4 times 3 must also be equal to 3 times 4, because if I had 3 in 4 columns, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or if I had 4 in 3 rows, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now what we've done is we've proved a fundamental property of algebra. Okay, maybe fundamental is not the right word to be confusing, but one of the main ones. Let's put that. Okay, so I twisted it just so you could see it. You don't have to abstractly think about it. Some people can't do that. So I literally turned it. Can you take your squares now, kind of squeeze them together, put your hands on them all, and just rotate it for yourself? And see that 3 by 4 is the same thing as 4 by 3, right? This shows what's called commutativity, the commutative property. And the way I remember this was commuting, like to work. Like if you take a train or the same bus. If you take the bus, it goes one route, and then it comes back the same route. So you could go from work to home, and that would be the same distance as if you went from home to work. That's commuting. I can change its positions, but without changing its value. Is everything commutative? Maybe, maybe not. That would be something to explore. Is 3 plus 4 the same thing as 4 plus 3? Is 3 minus 4 the same thing as 4 minus 3? These are things for you to explore, not for me to tell you. Patterns for you to see. Okay, let's keep going because we've kind of gone a little bit long on this one. But that's all right. Let's go to the graphical method. These are strip diagrams. I can push them together, and lo and behold, what do I have? I have the area model, right? And it's going to be 3 by 4, and therefore 3 by 4 means 4 times 3, which means repeated addition, which means 12 equals 12, right? Okay? 4 3 times is 4, 8, 12. 3 4 times is 3, 6, 9, 12. 12 equals 12. Is that true? Yes, it is. Yes, it is. Okay? Again, commutativity. Symbolic? Well, I can look at a number of ways, okay? So if I'm going to do a number line and I put my stuff on it, I might start at 0 because it's convenient for me, not that it has to be, right? It's just where it's easy, right, on these problems. They're easy numbers. I'm going to do what it says. I'm going to move 4 3 different times. So I'm going to go 1, 2, 3, 4, okay? There's my first 4. Then I'm going to go another 4, right? But notice that if I keep going, my number line looks a little short. Oh no, end of the world, crumble it up, give up, quit. No. Just erase your arrow, extend it out, and if you wrote it in pen, who cares? So let's skip count. I could say, okay, well I know that each jump will be 4. So one jump of 4 is 1 4. 2 jumps of 4 is 8. What's 2 times 4? Are you starting to see how skip counting builds your multiplication? So when you practice skip counting, you practice multiplying. And finally, I don't know why it keeps doing that. And finally, the third jump, 4 3 times lands on 12. Okay? 3 repetitions of 4. Or, what do you think I'm going to do next? I bet you're right. I'm going to do a skip count of 3. Well, if I'm skip counting 3, I'm going to have to do 4 repetitions. So that's the second repetition, the third repetition, the fourth repetition. And lo and behold, we land on 12 again. So now we have also shown ourselves the property of commutativity on a number line. It keeps reconfirming what is true or let's say mathematically valid. Okay? Number of repetitions, y. Okay. And finally, the abstract. So what do you think? Can I skip count on my brain? Absolutely. Can I start at the first 4 and count up? Do I have to start at 0? Can I start at 3? All of those strategies are available to you now. Okay? So let's do this mental math. I start at 0 and I skip count. 4, 8, 12. That's 3 4s. What did I land on? 12. What's my answer? It's 12. That's 3 repetitions of 4, right? Or 4 times 3 is 12. Okay, the ultimate goal is math facts, but do not rush to these. Now, this is for the teacher. Don't rush to the algorithm and the memorized math fact. Play with this. Let them digest it. It takes time, but that time is going to reap big benefits for you in the end. When they have understanding and they really know why things work the way they work, they won't be forgetting it, and they won't care about, you won't care if they forget the algorithm because they'll be able to figure it out, and then they'll remind themselves of the algorithm instead of you having to take class time to do it. So that's my motivational speech for you. All right? Okay. So this is the end. Again, there are my links. I want to thank you very much. This ran a little over, but I hope that it was rich with knowledge, and I will see you in the division.